Hello, welcome. Can you hear me? Okay, can you hear me?
Yes.
Okay, thank you. Okay, so basically today I will show you that how we can easily use the SAR data, mainly Sentinel-1 data, to identify the flood region. Okay, so let's just I simply share my screen and then show you that this process. Okay, so now can you see my screen?
Yeah.
Okay, so basically here you can see this is the result about that. I already do this result for this study area of select boundary, and mainly here we find out the two things. One is that flood inundation area. So this type of red color identify about the flood inundation area, and this type of blue color identify about the water body, permanent water body. Okay, so now how I can determine this is the flooded and this is the permanent water body. So basically in this time here I use here the thresholding value. Okay, so suppose you can see, first of all I will show you that. Suppose I just simply open my image. So here you can see the two images. One is the before and after. Okay, before flood event and after flood event. We can get that this is the before. You can see this is the before flood event, and we are also get this the after flood event. You can see lot of black pixel level will be increased. You can see black pixel level will be increased the after flood condition. So this type of pixel value we can get after the flood condition, and otherwise you can see before the flood condition we can get very limited. So basically in this time you can see for the before this type of black color, this type of black color pixel value identify about the water. Okay, so it's the identify about the water. So it's the water, it also water. So this water is the before flood. Okay, and you can say after flooding we can get this type of pixel value. Okay, so it also increasing the more water pixel value after flood condition. Now if you want to check about that, suppose before flood, what is the pixel value? Suppose click on the inspector tab and click on here. Suppose I click on here, so now you can check what is the pixel value we can get from here for the before flood condition. In this time here I can get the before. You can see you can get the before. The value is that 25. Okay, negative 25, and after we can get the negative 27. Okay, so you can also check it. Suppose click on here. In this time I can get the before flood condition, we can get the 27, and after we can also get the same 27. Suppose I will check in for the another. Suppose here I can get the result. You can see the before flooding value is that minus 19, and after flood we can get the minus 27. Okay, so as well as I just also open the after image, also you can see a lot of black pixel will be increased. Suppose I click on here, there you can say I can get the before is the minus 18, and I can get the after is the minus 20. So we can get the after mainly increase, negative value increase. Okay, after mainly negative value increase. So from here we are just set a condition using the thresholding value. Suppose in this time here you can see I set the thresholding value about this band, such as I just choose the flooded area and water. So here you can see for the flood condition we set before filtered, mainly before event, greater than minus 20. Okay, so here you can see the before. So this is the before. So we also filter about the before and after for the get the proper pixel value. So mainly it's the one kind of filtering get the proper image. Okay, so this is the before, mainly before flood condition, after mainly after flood condition. In this time flood mainly inundated, which pixel will be inundated. In this time you can see here the before filter greater than minus 20. I said the greater than minus 20, and also after filtered less than minus 20. Okay, because here you can see the pixel value. Suppose I just simply click on here. Here I can get the value look like that. Here I can get the before is the minus 28. Okay, and after minus 27. Okay, so for that I simply set here the before filtered greater than minus 20 and after filter less than minus 20. So using this condition, all of those pixel value I considered as a innovated pixel value or fraud pixel value. Okay, as well as same approach for the permanent water body. So permanent water body simply set at the before filter at less than. Okay, before filter at less than. Suppose in this time you can see the before filter at less than minus 20. When I set the less than minus 20, it considered as a water, permanent water body, and also after filtered less than minus 20. So all of this pixel value, mainly less than minus 20, we consider as a permanent water body. If you want to check about that permanent water body, suppose it's a permanent, so click on here. So now here you can see we can get the permanent water body. For that before, you can see the before we can get the minus 27, as well as we can also get the after filter at minus 28. So in this time we are just considered as the minus 20 pixel value, negative minus 20 pixel value before filtered. So in this time here we can get the two thresholding, minus 27 and minus 28. So basically you can see before we can get that low pixel value and after we can get the high pixel value. Okay, so in this time permanent water body, all of those minus 20 less than, as well as we consider it as a water. So now just we are applying these things in here using this thresholding value and then calculated the flood inundation. So now we can get this is the flood inundation. Basically this type of red color in this time we can get as a flooded area. So it's a flooded area, it's a flooded area, it's a flooded area. Okay, because in this time there is the no in and it's identified about the permanent. You can see it is a permanent water body. Okay, so in this time this permanent water body show the result for the before flood condition. So it is a before flood condition, and after flood we can get this type of red color pixel value which identify about the inundation or flooded area. So basically this type of pixel, you can see this type of pixel range is not fixed. Suppose for your region you try to check, first of all you try to check about that what's the permanent water body pixel value and what is the after flood pixel value. Okay, try to check this pixel value and then mention the pixel value according to your own region. Okay, then you can get the better visualization of the flood inundation area. And here I put here the minus 20. Suppose in this time I just put here the, suppose I consider the flooded area such as minus, suppose minus 25 and also less than minus 25, minus 25, as well as water consider as a less than minus 25 and also less than minus 25. So now we can check what the result we can get from here. Okay,
Laboratory.
so now here you can see we can get this type of result, and in this time some pixel value is not considered. Okay, so here you can see we can get the very low, very mainly it's identify about the permanent water body is the very low. Okay, and most of cases it show as a flooded inundation area. So for my cases for this study we can use here the minus 20, it's better. minus 20 is by better for getting the flooded inundation area, as well also identify the permanent water body. So just I put here minus 20. So now it's also better about that. We can easily get that pre-event and after, before flood and after flood. This type of pixel value is just simply set and then identify this is the flooded area, and also this is a permanent water body. So it's open. Okay, so it's a not suitable for the all the region. Okay, first of all, you have to check about your region. Suppose sometime for your region is very high flood. Okay, very high flood, then this value also be changed. Okay, so basically it's depend on your region and also flood condition. Okay, so for that you have to check, suppose you have to check some pixel using the inspector tab. You can simply click on the map and then check about the permanent water body. Suppose here you can see, you can easily identify about that before and after. So here you can see the before you can get the black pixel value. This type of black pixel value identify about the water body. Okay, and you can check it and also check about that after. Okay, so you can simply check about the before, what is the pixel about the before and what is the pixel about the after flood, about the pixel value. Then you can simply compare the result. Suppose in this time I compare the flood condition greater than minus 20. So before flood, before filtered, mainly pre-condition or pre-event of flood, all of those pixel value greater than minus 20 I don't consider. Okay, greater than minus 20, and after filtered less than 20, minus 20. So using this condition, I said it's a flooded area or flooded pixel. Okay, as well as all of those less than, so permanent water body I consider the before filtered less than 20 and after filtered less than 20. So using this condition, all of those things I could choose as a permanent water body. And it also depend on our inspector tab. When you click on here, you can easily get the result. Suppose here you can see it show the pixel value. So using this pixel value, it's vary. This it's will be vary from one region to another region. It also vary. Suppose in this time we can say we can get the before minus 30, and after we can get the minus 20. Okay, minus 30. So before we can get the minus 30. So in this time minus 30, I choose greater than. So all of those greater, you can see for the flood, we selected the greater than minus 20. So in this time we can get the for the before minus 30. Okay, but I take greater than minus 20. And also you can see after filtered minus 20. So in this time we can get the after is the minus 20. So just I put at the after filter less than 20, and using this condition we can set all of this pixel value as a flood and less than as a water. Then we are just make this type of flood inundation map and also make the permanent water map from here. As well as if you want, you can also calculate the area about that, how much area we can take from here for the flooded area. We can easily get the flooded area, how much area we can calculate that. Okay, so I also send you this code. You just try to practice for your own region. Okay, and okay, how to select region. Okay, what is the mean about the region? Don't understand. Region means boundary shapefile or other. Okay, so what the means about the region? Okay, how to select 20 value. Okay, so in this time here you can see for my region. For my region, I can get the pixel value. Suppose you can see I click on, I can get the before -30, okay, and after -20 pixel. Okay, so now from the before, I just put greater than, all of those greater than, all of those greater than -20 consider as a flat. Or you can see here we can get the -28. After we can get the -28. So in this time, suppose for the flat condition, okay, you can see about the permanent water body first. Suppose I click on the permanent water body, the blue color. So now you can check about that. We can get the permanent water body. For the we can get the VIC is the -30, and also get the before -30, and after we can get -20. So in this time, here we set about the before filtered greater than -20. Okay, all of those greater than -20, as well as also after filtered less than -20. All of those things consider as a flat condition. Suppose in this time, you can put here the suppose 25, or suppose 28, and also put here the less than -28. Okay, and also suppose put here the -28, 28. And now click to the right. This time you can see what happened. Okay, so now you can see it loaded. In this time you can see when I increase the value, suppose I just take the -28, you can see -28 greater than -28, and also greater than 20. Now we can get the sum similar. Okay, you can see we can get the sum low inundated area. Okay, so in this time, this type of pixel, this type of red color pixel will identify about that greater than -28 and less than -28 from before flood condition image and after flood image condition. So very low. In this time, it not the proper value for my study area. When I put at the -28, I did not get the proper result, because in this time lot of flooded area are not considered for this. When I put at the -28, so it's not considered for that. Okay, so you can see in this time this type of region is not considered, because if you want to check about the value, this value is the showing about that, you can see -24. Okay, -24, but in this time I put here the greater than -28. So that's why in this time this type of pixel it not considered as the inundation. But when I put here the -20, this value is the totally perfect for my study area. Suppose -20, and also put here the -20. So now it also considered as a -24 also. Suppose I put here the -20 and also put here the -20. So now I can get the proper result. In this time when I run the code, we are also get all of those inundation area very properly. Suppose now click to the run. And you can see the another reason is that for the 20, here you can see I can get, suppose click on here. Here I can get the minus 25 and also minus 27. Okay, for that both of pixel. So in this time, you can get this type of value minus 25 and minus 27. So you should choose a value less than, suppose 25 and 27. You can choose the value 20. It also better. Okay, suppose you can get the minus 25 and minus 27. So in this time, when you choose here the 20, then we can get the proper map. Okay, suppose you can get the suppose 35, or also put here the 37. Suppose before we can get the 35 and you can get the 37. So then you put here the less than 30. Then you can put here the thresholding value 30. 30. Then you can get the better value. Okay. Suppose you can get the 45 and also get the 50. Then you can put here the thresholding value for the 40. Then you can get the better pixel value. And all of those flooded area will be calm. In this time here you can see when I put here the, I can get the minus 25 and minus 27. I just put here the 20. I can get the greater than minus 20 and after minus less than minus 20. So now all of those flooded area as well as also permanent water body easily show in my map. Otherwise, when I increase the value or decrease the value, then we did not get the better result about that. Okay, so basically this is the process about the thresholding. You have to put some value, also consider about your pixel value from here. Then you can just put here the value, and which value provide you the proper map, then use it and get the proper flood inundation map. And there are a lot of technique for identify for the flood inundation thresholding value. So if you want to simply search on the Google, suppose I show you that, suppose flood, and see suppose a local thresholding approach to flood water delineation. As well as also get the some paper about that. Okay, so here you can see the a local thresholding approach to flood water delineation using the Sentinel-1 SAR imagery. So you also try to read this paper. Here you can get the more a lot of information about that, how we can easily use the best thresholding value to identify for the flood. Okay, so I have to send you this paper link. So you also try to read the paper. I hope after reading this paper, you can easily identify what's the better value to identify for the threshold value to identify the flood water or flood inundation map. Okay. Okay. So any questions? Okay. So could you show the overall process? Overall process. So mainly, first of all, you need to select your image. So basically, first of all, you have to choose your Sentinel-1 SAR image. Suppose here you can see we just simply imported our image collection Sentinel-1. Okay, from here we can just use at the VIS band. Okay, transmitter receiver polarization. This band I use in here, and put here that instrument mode IW, and I put the orbiting process pass as the descending. Okay, then simply I select the before flood condition time and also after flood. So just this collection we just filter for the time period. Okay, suppose before and after, and also filter bounds with or region of interest. After that, this is the image we can got. This image we can got, and from here we are just, suppose after this image we are just put here that we can see this image we can got after filtering. These two images we can got. Okay, so one image for the after flood condition, another image for the before. So this is the before and this is the after. Okay, after getting this image we have to remove some noise means that unnecessary pixel value. So further we are just use this function for removing some unnecessary pixel value or ridicule from this satellite images. We simply remove. After that we are just put here this thresholding value for flood region and water. And what is the function about that? So this is a very long function you can see here. uh, yeah, so you can see speckle filtering function. Okay, so basically this function it's start from here and up to the from here. That's very long function. Basically this function we are used to remove the speckle from this Sentinel-1 SAR data. Okay, this function you have to use speckle filtering function. Then we can get this type of image. You can see before condition and also get the after condition. You can get the two images after applying the speckle filtering function. And after that we are just put here the thresholding technique. So just put here this thresholding technique just as less than -20, greater than -20. You can see just put here this, yeah, this condition about that -20 and after less than -20. Okay, and how we can select these things? Just simply check the pixel value, and then from the pixel value you can simply select for your what is the best value for you for your region. In this time I can get the -26. So I just consider all of those minus greater than 20. Okay, suppose -25 I can consider as a less than -20 about that. Then put the flood and also water, the same process, less than -20, and after flood less than -20. Then consider as a permanent water body, and then display the result on here. Or we can get the flood inundation map, also permanent water body map. Okay. Okay, so I also send you the code. You also try to practice for your own region. Okay, and after that you face any problem, then send me the code link about your region. Okay, then I also guide you how we can get the proper thresholding value. So you try to first for a developing implement this code on your study area. Okay, so I send you the code. You try to implement the code. Just set the before and after condition. Simply put the time period. Suppose before flood time and after flood time. Further, you just check the result first, and then send me the code link. I also check about the code link. Then I also send you the proper feedback. Okay. Okay. So you also try. Okay, I send you the code. No problem. You can try to practice. Okay. Thank you. Okay. Okay. Thank you. You can check it. Okay.